All right, good afternoon, good evening to everybody out there. And especially if you're out there listening on shortwave on WBCQ 7490, we welcome you. You're listening to Amateur Radio Roundtable, a show about ham radio, shortwave, and other things kind of in that category there. No telling what we might talk about tonight. Uh, anyway, we welcome you, and also for our people that are tuned in to the video show tonight, we welcome you and ask you, if you will, please hit that subscribe button. It's down there in the bottom right. Hit the subscribe button and hit the notify, hit that like button. It helps us to advertise our show to other YouTube people that are, kind of surfing around YouTube looking for shows about electronics or radios and different things like that. So anyway, do that. Join our Facebook group. Our Facebook group is just W5KUB. And just if you'll join it, we'll approve you immediately. Just search for W5KUB, and you'll find us there. We've got about 14,000 people in that Facebook group. It's a great Facebook group. Man, we have not had any spamming in there, really, or any shoe advertisements or anything like that. Like some of these other groups, they get bombarded with and even stuff worse. So we're doing really good there. Again, hey, if you're out there on WBCQ, send us an email to tom@w5kub, tom@w5kub.com. Let us know where you are and how you're hearing the station tonight. Relatively low power, about 50,000 watts, but we should be getting out to a number of international locations. And again, we're on just about any podcast carrier out there, from iTunes, Google Play, iNet Radio, all those. You can hear this show there. If you're at work or driving, just check us out on your podcast carrier that you use there. Hey, tonight we've got several things we're going to be talking about. Antennas, we're going to be talking about, I think, grounding and bonding. I've got a few things here that on my list here that I'll mention, and we'll get started here. Let's see. It seems like I'm forgetting something. I don't know what I'm forgetting here, but it'll come around here. Oh, hey, we're not going to have a show. I think we will not have a show December 26th. Is Christmas on Monday? Is that right? Anybody? Okay. The day after Christmas, that Tuesday, we will not have the show. And also on January 2nd, we will not have the show. So we're going to take a break from that and kind of enjoy the holidays there. And we'll be back with you that next week there in January. Let's go around the room and say hello to our remotes out there. And looks like to me we've got Brett up first. He's there. Hey, Brett, there you are, man. How you doing, Brett?
Oh, well, I'm not up right now, but you can see a picture behind me of me up on the tower earlier. This is me climbing the tower to get antennas ready for the winter, and I need to because it's going to be snowing this weekend. We're going to have a white Christmas,
Oh
so I've been
boy.
doing that and also checking the grounding and the bonding, which I want to talk a little bit about tonight.
All right, all right. Now, your beard on the tower looks a little bit longer than it is now. What's going on there?
Oh
Is
yeah,
is that
well
your
this
winter beard that's on the tower?
Oh, that's that was this picture actually was taken a little earlier in the year, although it's the same tower that I climb about once a month. But it's yeah, this it's and also I'm in shadow a little bit up there, which is good because it was a very sunny day. But yeah, that's the tower where most of my antennas are.
Well, I know you're going to talk about some grounding tonight, and you're talking about climbing a tower. Rich there in the chat room, he says grounding is when you fall off the tower. So that may be a different. You're not going to talk about that type, but uh,
Ouch.
that does happen. So we got to be careful there. All right, well, let's. Hey, Glenn, come on in here, Glenn. Come in,
Yeah,
Glenn. Come in, Glenn. How you doing,
I'm in,
Glenn?
Glenn. Yeah. Hey, what's up, man?
All right. So how you doing, man? You look happy tonight. You got a smile. Are you are you still working or are you out now?
I'm out
Good.
temporarily, permanently, still waiting to decide on that. But until further notice, I get to sleep in. And
That's nice.
yeah, it is. For all intents, we can call it semi-retired. And right now, just today, I heard from ARRL, and we're starting the editing process on my book for them. So when that starts, that usually means it's going to hit the printer,
Oh boy.
soon. We're talking February, March, thereabouts. Maybe out in time
Yeah.
for Orlando, but most likely we'll be out in time for Dayton. So the new book, everybody get your credit cards ready, and it'll be out.
All right. Well, you need to stop writing the books and do some hamming and have some
Oh,
fun.
that's
'Cause
that's the plan.
yeah,
I've
okay.
got
All
the
right.
the house painting is 99.9% done. The weather's going to be good the rest of this week, and once that's done, it's fixed the cobweb antenna, and the shack's already ready to go. I just need to tie down all the wires with some wire ties,
Yeah.
and yes, I plan to be on the air this winter.
So hey, let me just give you. I've been retired now about 10 years. Let me give you some maybe a hint or just give you some information about retiring. You like to sleep late, right?
Oh gosh, yeah, I'm
you think
learning.
that's gonna be
I'm
good.
learning that I
All right.
love sleeping in.
Here's what you're not gonna like. When people knock on the door and ring the doorbell at 8 o'clock in the morning, you ain't gonna like that, okay?
Nobody comes to my house at that hour.
And I don't know anything about your car right now, but you're gonna get a call about 8:15 about your car insurance, okay?
Oh yeah.
You'll get that. All right. Just wanted you to be aware. That's kind of goes on.
Fortunately, fortunately, most I don't get a whole lot of phone calls, so
Yeah.
I don't really have a lot of those now. I do get a ton of email,
Yeah.
but generally my phone's it's a newer Samsung, and it's got this automatic feature that I'm assuming that if it doesn't hear audio, it goes into silent mode and it doesn't hit any alerts unless it's something really special. So I don't
Yeah.
even get email notices until I wake up and make some noise, or if the cat jumps on the bed and makes noise. They've figured that out.
Well, other things to look forward to. I mean, I've already experienced this. 4 o'clock in the morning, a 100-foot tree falls through your house.
Oh yeah,
Your
that's
alarm,
gonna
and
happen.
see, it's ice. It's ice outside. Everything's covered with ice. You're having an ice storm. A 100-foot tree falls through the roof of your house. Instantly, your alarm goes off.
Oh
Woo,
yeah,
woo,
oh
woo.
yeah,
You
that's
hear this.
coming.
You hear this explosion. It knocks you out of bed at 4 o'clock in the morning, and you think, "Oh man, did my water heater explode? What happened?"
That
So,
actually happened about 20 years ago.
well,
My neighbor's sassafras tree fell over in the wind and literally fell into my pool. And we're talking about 40, 50 feet worth of tree.
well, it happened to me too. I've had several come down
Yeah,
here, and it's no fun. I had to replace the driveway. I had to replace the
yeah,
garage doors, replace the roof, replace a lot of stuff actually. But hey, wow, that's enough. Hey,
yeah,
let's go
it
out. Let's go out to
happens.
California. Let's see what Jim's doing out there. Jim, you had a tree fall through your house ever?
No,
Go on in, Jim. All right.
no, I haven't. We had other stuff happen, but not that. So, good evening from Rockland, California.
Rockland.
Rockland, yeah, Rocklin.
Now, where is that?
I'm still trying to figure that out. It's east of Sacramento,
Okay.
about a 15 to 20-minute drive. Next big city over that's known by more people than Rockland is called Roseville. And a lot of industry here, a lot of big name companies, office buildings, that kind of stuff. So it's a highly developed area. And there's some dirt that hasn't yet been built on, and stuff is in the works to build multiple houses. So we're going to see a growth in traffic, which is already kind of bad anyway. So anyway,
Well, we're talking about trees and stuff falling to the house. I don't think you have that problem, but one of the things you got to look forward to is when this earthquake breaks California off and you guys float out into the ocean.
I've wondered when that's going to happen because we're overdue for something like that. And the 1971 earthquake was really bad, destroyed a lot of big buildings. If it happens again, I think it's going to be worse.
Yeah.
Yeah, but you're going to have beachfront property if that happens.
Yeah. Yeah, boy.
Well, that's something to look forward to, I guess. All right, there, man. All
Not
right.
really.
All right. Well, hey, all right. We'll get started here in just a minute on some of the subjects that we're talking about. Hey, I want to show you guys something, man. Do you guys like taking your car to the dealer? Glenn, do you ever take your car to the dealer for anything?
I think I would rather have a root canal without anesthesia.
Yeah, maybe a colonoscopy or something like that. But
something like that.
Guys, let me tell you, let me tell you a little quick story here. It's kind of electronics related. So Kathy's backup camera in her car stopped working. Well, I've been in electronics and design and troubleshooting all my life, but let me tell you, on a modern car, you can't trace nothing. They got every wire, they got 800 wires bundled. They got them going through pieces of metal that you can't even know where they're going to. You don't know what modules do what. There's 14
that's the
computers.
Other thing. They've got that CAN bus, and everything ties to that bus. So
let me tell you. Okay, so her camera stopped working. I pulled the camera out. The camera looked okay to me, and I put it back in. But we checked for fuses. We checked for different things, but it just wasn't working. So I said, okay. Well, in a place that normally does maintenance on her car, of course they wouldn't touch it because it's an oddity working on the camera. Automotive shops just don't work on cameras. And I told her, I said, even the dealer isn't going to know what's going on with this thing. They probably get 1 out of 1 million of these. So anyway, we don't have any resort, but take it to the dealer. And so the dealer takes it and looks at it and tells me that the kryptonite paraphase thunderbolt greaser slapper is bad. All right. So
say it again.
The kryptonite paraphase thunderbolt greaser slapper.
Could you spell that? I'm not sure what that is.
CYRTO.
That's okay. You can send it to me in an email.
Yeah, I will.
In a Toyota, they call that the flux capacitor.
The flux capacitor was the next stage. Now, so anyway, so they say, okay, it's that's bad. And in fact, I've got it here in my hand. Let me show you what it is. There you go. There's the kryptonite paraphase thunderbolt greaser slapper right there. You see it right there, guys? The little card right there.
Oh yeah, that's all flux stuff.
You see that right there? Yeah. Now, Glenn, what do you think his little card cost?
What make is the car?
It's a Volvo.
Oh, Volvo. Oh
Yeah.
Shoot, you're probably talking $1,300.
What do you think, Brent? Anybody?
300.
I wish. Made me laugh. Oh, well. Guys, so they tell me, all right, first of all, it's going to cost $175 just to look at it. That's a given. They call me and they tell me, okay, this car is $1,183. All right, $1,183. And do I approve it? I said, well, is that going to fix it? Well, it could be more than this, but we think this is bad. We got to put this in. And I said, are you telling me that I've got to pay $1,200 for a car and it may not fix it, and I have to pay this? And they said, well, yeah. But they don't have any way to test this stuff. Although I would think a reputable dealer would have something like that maybe in stock and try it. And hey, if it don't fix it, you put it back in stock and you use it to troubleshoot the next car, right? Well, anyway. All right, so $1,180. All right. And if this didn't fix it, my option was going to be leave there paying about a $1,400 bill with this new card and not having my camera working, or I could roll the dice and maybe the next in line $1,200 card might fix it. Would you roll the dice or not, man? I mean, you know, I don't know. So
Tell
anyway,
your wife not to back up.
yeah. I always park where you can go, you know, always look for a pull through. So, yeah. So, anyway, so here we go. $175 to troubleshoot it, $1,280 for the card, $150 to put the card in. And I don't know. So I don't know. The bill was like $1,300 or something, but it did fix it. It did fix it. And I'm thinking, oh man, what a relief it is, man. Just like Alka-Seltzer, man. What a relief.
Yeah, but that's part of the issue is the troubleshooting skills of modern mechanics don't extend to digital and these integrated circuit boards. They're they're old school, spark plugs and spark plug wires, that kind of stuff.
You know, I don't know if you can see it. I didn't get a really good picture. I tried to zoom in here. If you look real close, there's a lot of corrosion on this side of that card.
Yeah.
Look at the top. See that big chip with all the pins on it? Look to the top right corner. You're starting to see corrosion all up in that area and over toward the center.
Yeah.
I mean, it's a lot of stuff going on here. I don't know what caused that.
Where in the car is the
yeah. You tell me, where is it? They told me it's in the trunk area. So I said, where is it? In the wall? Is it in the fender wall, or where? Or is it under the floor of the trunk? And the lady told me, she said it's probably under the floor of the trunk there. So.
Well, you also have to remember with a car, that trunk is getting heated and cooled, and it's gonna condensate and stuff like that all the time.
Well, now they did tell me, hey, I got a lifetime warranty on this card. I got if it's not wrecked or put underwater, I got a lifetime.
Wait a minute, shouldn't you have had a lifetime warranty on the first card?
I didn't ask them that. I just left, man.
I would have done the same thing, man. I want it out. Get me away from here.
Yeah, man. Anyway, so that's my story tonight, and I'm sticking to it, guys.
Wow.
All right. Well, hey, let's jump over to Jim, and Jim has a video he's put together about 3 different antennas and how they work, I guess. So, Jim, come on back in here, and I've got your video queued up here, I think, and I can play the video when you get ready.
Okay, I did unmute. Okay, yeah, it's sort of a continuation of a prior video, and how does the voltage and current distribute on a half-wave antenna, and what's the difference between an in-fed, off-center fed, and center fed? How does that change the way that the current and voltage appear on the antenna? And so I did my best to draw this animation. And I'm no animator, and it's not great, but I'm trying to show where the maximum current is and where the maximum voltage is, and how it, because it's an alternating current, right? It's AC, how it appears on the antenna. Unfortunately, we can't look through something and see it, so we have to depend on animations like I drew. Tom, if you want to run that, I think the whole video is 5 or 6 minutes long, and I uploaded it to YouTube.
All right, we've got it going right now. Well, let's see here.
Hi, I'm Jim W6LG, your ham radio Elmer. Welcome to my radio room here in Rockland, California. A half-wave antenna could be a dipole, could be an off-center fed dipole, could be an end-fed antenna. Is there much difference between those 3 antennas? I prepared an animation. It's not perfect, but it'll help show what I think happens with a half-wave antenna. So let's talk about that after we watch the brief animation. It's only, I think, 1.5 minutes long. So here we go. An animation showing a half-wave antenna. This is the first of 3 animations that I drew showing a half-wave antenna. As shown, this is a half-wave dipole, being fed in the middle, where the highest current occurs, also the greatest radiation, and the lowest impedance. Impedance would be somewhere in the neighborhood of 30 to 70 ohms, depending on its configuration and its height above ground. Greatest voltage is at the ends of the wire. It's also the highest impedance. It's also the location of the least radiation. Greatest radiation occurs in the middle. If we slide the feed point to the left, it becomes an end-fed half-wave antenna. No counterpoise is needed, doesn't need any kind of radials. It's a complete antenna. High current is in the middle, highest voltage is at the ends, highest voltage occurs at the feed point, have an impedance somewhere in the neighborhood of 5,000 ohms or so. If we slide it over just a bit, we can drop that impedance to maybe 2,500 ohms, and this becomes an off-center fed dipole. Everything remains the same. The highest radiation occurs in the middle of the wire. The highest current occurs in the middle of the wire. The impedance at this point, as I said, is around 2,500 ohms. And again, no counterpoise is needed, no radios are needed. Let's take a look at those animations. In particular, we're going to take a quick look at 3 still pictures that I grabbed from the video. So let me put that up on the screen now. This was the first one, the regular dipole, center fed. Works great. It's a terrific antenna. You can get a pretty good prediction of where the pattern is going to go. It's also the basis for many, many antennas. For example, my Yagi antenna basically looks a lot like a dipole in the center, and it has a reflector and a director. So basically, it is like 3 dipole elements. As we look at this, high currents in the middle, as is the feed point. The high current, or rather the high voltage, is on the tips of the wire. If this was a vertical, or was configured with a 90-degree bend right at the feed point, and it was sitting on the ground or maybe a few feet off the ground, again, the high point, the high voltage point would be the top of the vertical and the end of the radials. Maximum radiation does occur in the middle. This would do the same with a vertical. Okay, let's look at one other picture here. So that's a brief view of a standard half-wave dipole. Okay, this animation is, this frame from the animation shows again the high voltage, high current, maximum radiation, all in the same place. All we do is move the feed point down the wire, either from the center out to a point where the impedance is somewhere around a couple thousand ohms. Again, it's a predictable antenna. If one leg was cut for, I don't know, pick a band, let's say 20 meters and the other leg for 40, it might give you 40, 20, and 15 all with one wire. It's a terrific antenna for that. It has some neat tricks that can be done. Again, the high voltage is on the tips. A little bit more difficult to feed as we get closer to the end of this wire. The feeding of the antenna, the connecting of a coax, requires some work. In this case, the impedance of the antenna would be around a couple thousand ohms, so it would have to have some kind of transformation to make a good connection to coax, for example. And this is clearly the most popular antenna today. Can be used on POTA, can be used in the backyard, can be used in an apartment. It's an end-fed half-wavelength antenna. Again, the current distribution is the same, the maximum radiation is the same spot. The impedance at the end can be several thousand ohms. By that I mean 5,000, 6,000 ohms, depending on how you're hooking it up and what you're doing with it. But it's a predictable antenna. Many like it. Again, you don't need to have radials because this is a complete antenna. No radials are needed, no counterpoise. I'm Jim W6LG in Rockland, California. Thanks for joining me. If you haven't subscribed, please subscribe. Thumbs up, thumbs down, thumbs whatever. I'm Jim W6LG saying 73. See you the next time. Bye-bye.
All right, so we looked at two or three different antennas there. And, Jim and I were talking before the show. When we were novices back in the early 60s, we didn't even know what a off-center fed was, or that nobody was even using, that we knew of, what was called an in-fed half wave. That might have been great for us because we were stuck with a single band dipole or something.
Exactly. I was that way.
Yeah, yeah. So, I'm contemplating right now. I don't have I do have some in-fed antennas up, but they're verticals, and they're in-fed. I'm contemplating whether to put up a horizontal in-fed or not.
Let's talk a little bit about the impedance of the antenna, because a couple of comments were that I misspoke on the impedance. Not really. It depends on where you're feeding it. So as you slide that feed point over towards the end, the impedance gets higher and higher and higher. And technically at the very end, it's infinity. So a lot of people will bring that in a bit to where it's 2,400 ohms or some number that works. So don't get hung up on the diagram about where the placement of the coax was. I'm just making the point is the impedance changes as you slide that feed point down. It goes very, very high. And then it becomes a little bit more difficult to feed the antenna. You're dealing with really high voltages. You're dealing with perhaps some heat also. So those things need to be considered if you're going to make an in-fed half wave. I've seen YouTube videos from folks who get around, and some of them recommend putting radials on the ground, just laying out wires. That has no impact on a dipole. It's up in the air. And if you stick, others recommend like a 20-foot piece of wire coming off the other end at the feed point. Well, then that's no longer an in-fed half wave. It's an off-center fed dipole at that point. And some recommend taking that counterpoise and running it to ground into a driven stake. That makes no sense to me at all because, again, it's a dipole, and you want the dipole up in the air to radiate, not tied to ground. Brett's going to talk about grounding. I don't think that's in the scheme of things that Brett's going to talk about.
Yeah. You know, one of the things I've been thinking about doing, Jim, is I would love to get a couple tape measures and use the tape for the wire, the element, like a dipole. Take 2 tape measures, feed it with some coax, hook it to an antenna analyzer, and just slide that tape, to the left or to the right. Yeah. Slide it.
This one's broken. That's why I've hung on.
Slide it to the right or left, and watch that impedance go up and down. And as you get to, as you get to the off-center fed, you're going to see it up to like 200 ohms or something. And
I think this one's 30 feet. It's broken, so this is perfect for that kind of dipole, where you can slide it and look at it with one of the analyzers.
So there's several ways to match that. The best way right now, of course, is with a toroidal ring, a ballon that you can wind. Again, like Brett was saying, 49-to-1 is what you need for a off-center fed. For a half wave. For
an in-fed.
In-fed half wave, you need a 49-to-1.
It depends on the length of the wire.
But a half wave. I'm saying a half wave, it needs to be a 49-to-1. But if it's a random link in-fed, then you need a 9-to-1 ballon to match that.
Yeah. On my Yagi, because my Yagi basically is a dipole. The driven element's a dipole element. So I get it up in the air and I test it, and the impedance is wrong. It's not matched. So I used a hairpin match on that with a slide, and I moved it back and forth until I got it to about where I wanted it, where I had little reactance, and it was close to 50 ohms, and called it a day, and it stayed that way.
Well,
There's lots of ways to match
yeah,
antennas.
and you had you talked about the high voltage on the ends there. In my experimenting with my end-fed, I've got an end-fed halfway vertical out there, and I've got an end-fed 3/8 wavelength out there where I use toroids and to match. But you could match that with a quarter wave piece of open line. Your 300 ohm open line, and so I did that. Yeah, I put the quarter wave open line out there, and I had it. It was off the ground, maybe a foot off the ground. I had some little stakes sticking up, and the matching went kind of sideways down there. I came in, and man, it had a perfect match. It had a beautiful match using that. And I went back out there and looked at it, and the matching line, the open line, had actually caught on fire, and it was dripping. It was dripping out there in the flowers, little balls of fire. So I made me some open line. I made me some little 6-inch spacers with some really small PVC pipe and just some number 12 or number 14 wire, and put that out there. And I didn't have any trouble anymore. So, man, there is really high voltage there on the ends, believe me.
Yeah, it's and a lot of people don't know that, and you got to be careful about. You need to know about that it possibly could get not just warm but hot.
Oh yeah.
It's also a good idea to have a choke on it to make sure that none of that comes back at you down the feed line.
Absolutely.
You want to put ferrites on it or wind yourself an air choke several turns in the coax.
Well, and I did a lot of studying on that particular thing, and like Jim was saying, some people say you need a counterpoise, and some people say the coax is the counterpoise, and all different things. But in reality, there's some engineering papers done on this, and they showed that I think it was 0.06 lambda or 0.06 wavelength, which was, I don't know, on 40 meters it was like 6 feet or something. And so on your coax feed about 6 feet back, or whatever 0.05 wavelength would be, about 0.05 wavelength back, they put that choke like Brent's talking about, and that really made that antenna function really well. And I think what it was using that short 6-foot piece in there. That was optimum, to get this thing working. But there's so much going on with these antennas, guys. The type ground you have, surroundings and things, man.
I want to make one more point.
Yeah.
And first of all, get out and do it. But get it up in the air, whether it's perfect or not. Get on the air with it. Have some fun. So maybe it's not the perfect end-fed, or maybe it's not the perfect dipole. When Tom and I are ancient, and when we started out, the antenna of choice was an inverted V. Right, Glenn? And so get on the air. Do it. Put it up. Have some fun. Don't sweat the little details. Do the best you can. Get it up.
Well,
and see what happens.
That's exactly right. Get you a piece of wire up in the air. And hey, back then, we didn't even have an SWR meter. We didn't even know what SWR was. We didn't know what it was.
No idea. Not a clue.
Yeah. But guess what, guys? We put a wire in the air and we talked to people on it.
Yeah. I mean, the rule of thumb for me and for most people was, hey, if it's 3-to-1 or better, you're gold. Go for it. Don't sweat this 1.5 versus 1.6-to-1 SWR. Just go.
Yeah, because your transmitter had a Pi network in it. Yeah. And you could match anything with it pretty much.
Yeah.
Well, antennas are fun to build and experiment with, and I've got so many wire antennas out there, guys. A bird can't fly through my yard. You run I try to run my antennas mostly north and south because the lobes are more east and west. On a dipole like that. But hey, if I want to cover north and south, maybe I ought to run me another dipole east and west. I mean, there's all kinds of things to do there. antenna experimenting and playing with is a lot of fun, and it's easy to do, and it's almost no cost. I've always wanted, and I tried again this past week, to look at some modeling. You know, the EZ NEC models or the 4 NEC2 models. Let me tell you guys, those things are so complicated. Either I'm getting too old. I went through a video and watched the guide. He said what to do where, and man, it's like going through a minefield trying to set that EZ NEC antenna modeling up. So if there's anybody out there, including you co-host or anybody out there in the chat room, that you're good, well, let's say great with the modeling programs, I'd love to have you come on here and run some models for us and show us how that works. So, oh man, I gave it up.
I've got a guy in our club that does that, but it's well above my pay grade.
I gave it up, man.
I have tried it and found that it didn't correspond to reality because environmental conditions, metal objects in the area completely threw things off. And so I just went to what I'm a fan of now, which is using a remote tuner right there at the feed line to match whatever it turns out to be, because then you don't need to worry.
You don't.
No. I talked to a guy, I don't remember where he was, but let's just say more than one guy will say, well, I've got a mountain near me and I think it's going to ruin. You got a 30-degree takeoff angle. That mountain's not in the way. Put up an antenna, get on the air. Stop. Don't take this the wrong way, but don't make excuses. Go do it. Get it up, see if it works. If you got it north, south, and you're not happy, put up another one east and west and see what's going on. You're missing out on too much fun. HF, especially now on 10 meters.
Our place, hey, HF will get out, guys. At our place over in North Carolina, our house is built right on the side of a mountain. It goes up behind a house. And then not too far, I'd say a quarter of a mile or more out the front, there's a little creek right there, and then another mountain that goes up, I mean, just really high. But hey, I make all kinds of contacts there on HF. I can go to any band, and man, they're jumping. So, hey, put your piece of wire in the air and it'll work. The thing about it, you're not going to see where it's going. You're not going to see it. You might look at some of these programs are interesting. Like, is it PSK Reporter? And some of those programs, it'll actually pick your signal up and it'll draw you a map and report to. And a lot of times, and that's not to people you're talking to. It's just a report that says your signal was heard here. And I've seen people that use that, and they might have, they may have hundreds of contacts to the north and to the east and to the south, and maybe just a fewer contacts toward the Midwest, maybe some contacts toward California. But you got to think about it. There ain't anybody out in the Midwest. I mean, there's one person every 500 miles out there. There are very few hams out there. So, the population areas, the northeast and southeast, and, from the Mississippi River to the east, that's where most of your
I'd like to make one more point, and that is, if you have the opportunity, engage the person that you've made contact with in a conversation. Now, some DX stations are just going to say 5 now and move on to the next one. But there was a guy who worked just a couple of days ago, 7Q6M in Malawi. I've forgotten his name. Anyway, I heard him testing, and he was trying to fix his transceiver, and that was long path that I worked in. And I engaged him in conversation, and son of a gun, he grew up 1 block from me in Burbank, California. And here's a guy in Malawi on the long path, and he was about 10 years younger than I. So I missed him at school, and when he got his ham radio license, I'd already ventured away from. I graduated from the university, but I was talking to him. I asked him where he grew up, and because he had a California accent, and he said Burbank, and I just about fell out of my chair. And he said the street he was on, it was the next street over from where I grew up.
Oh yeah,
So
Yeah, you run into people like that all the time. You know, it's
yeah,
amazing.
it is.
Yeah.
All world.
All right. Well, hey, this has been fun talking about antennas, guys. Just throw you some wire up out there and try it, man. You know, you'll make some contacts, believe me. All right. Hey, Jim, thanks for putting that together for us.
You're
And
welcome.
we really appreciate it, dear. Hey guys, let me jump back to just another quick announcement here, real quick, and you guys don't go away. Let me see where am I? I'm right here. Um, I'm looking. Oh, okay. I still haven't heard. No one has found me an All American 5 radio yet. I need an All American 5 radio. I guess I could go down to Salvation Army or Goodwill, and there'd probably be one in there on the shelf I could get for $5. But I need an All American radio. All American 5, there's millions of these things built. We're going to convert this to a broadcast transmitter with no extra parts, and I'll send it back to you when we get through. It's just going to be a project for the show. An All American 5, and give it to your kids, give it to the neighborhood kids, and let them put their own radio station on. The one I'm looking for has the miniature tubes in it, like you see here, the little 7-pin miniature tubes like the 50C5 and the 35W4. That's the two tall tubes right there. Not really interested in the I think they're Loctal tubes. They're the 8-pin. I think they're Loctal or Octal. I forget which ones. But I'm interested in the 7-pin miniature tubes like this. So, guys, if you can find a radio like this, find it. I'll pay the shipping. Just find me one, and let me get it. It'd be nice if it's working, because I don't have any tubes anymore to repair it. So it needs to be in working condition here. So I need an All American 5 radio. They come in many different brands. There you go.
That's a 50C5 and 35
W4.
Thanks.
50C5 is the audio output. 35W4 is the rectifier.
All right,
Yeah.
that just shows you how old I am.
Yeah. And I don't remember the others. 12BA6, 12BE6, and was there a
12BE6.
Was there a 12AV6? I don't remember the three small ones, but
Well, there were some audio tubes in there, so it's one of those.
Yeah. All right, guys. Let's see. Don't remember what band. Let's see. Yeah, I'm sure Martin's got a couple down in his, but Martin collects things. I don't want to take a collector radio and trash it. So I'll go to Salvation Army and go in and see what. I look at Facebook a lot of times, and guys are picking up shortwave receivers, really nice shortwave receivers, at places like Salvation Army. I don't know if my place here would have anything like that, but there's some good finds.
It's worth taking a trip.
There's some good finds on radios like that, So I'll look at that and see. Okay. All right. Hey guys, we'll be back in just a minute. Don't go away. We've got Brett coming up here. We're going to talk about maybe some grounding and bonding. We'll be right back. For the outdoor ham who loves POTA and SOTA activations, these radios would be great to put on your Christmas list. The IC905 and IC7300 are your top choices. Explore the world of microwave with ICOM's new SHF portable, the IC905. This all-mode rig covers 2 meters, 70 centimeters, 1.2 gigahertz, 2.4 gigahertz, 5.6 gigahertz bands, and with the optional CX-10G transverter, it'll cover 10 gigahertz. It has a large 4.3-inch touchscreen, real-time high-speed spectrum scope and waterfall display, easy digital mode settings, high-performance GPS antennas, and it has full D-Star functions. The IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed expectations. This innovative HF transceiver digitizes RF before various receiver stages, reducing the generated inherent noise in different IF stages. This is a radio that changed the way entry-level HF is designed. It has a 4.3-inch touchscreen, real-time spectrum scope, and 15 discrete bandpass filters. Visit www.icomamerica.com for more information on ICOM radios. All right, we are back. I'll turn the echo off here. All right, we're back. Let's see. Boy, something was on my mind. I was going to mention it to you there. Oh, what I was going to mention to you guys is, of course, we all know that Christmas is coming up here real soon, and we got a few Christmas pictures here. Look at there. Man, there's Santa Claus right there. What kind of radios? Anybody recognize radios there? I don't know if some of those are vintage or if they're all new. I can't tell.
Oh, there's an old Kenwood.
Yeah. What's the bottom one on the left? Anybody recognize that? Don't know what that is.
Has the look of an atlas.
Yeah, it does. It kind of does. That looks like it might be a scanner up on the top there, on the top right. I don't know.
Yeah.
Let's see. Oh man, what is this thing? I don't know. What
I don't recognize that one.
That must be a home brew rig right there.
Yeah.
Let's
Now
see.
we had Santa at our club dinner the other day.
Oh, did you?
And, oh yeah, man! I hopped in his lap and asked for all kinds of stuff.
All right. Well,
Yeah, he looked at me and said, "Coal, buddy,
Look
coal."
here, man. Well, how would you like a Lego set, man? You can get you a Lego
Yeah.
set for ham radio right there. That'd be kind of cool right
That'd
there.
be kind of cool.
Yeah. And then there we go. There's Santa sending and the kids receiving him. It looks like on a crystal set. All right. So let me make an announcement here again real quick. You are listening to Amateur Radio Roundtable, a show about ham radio, shortwave electronics. We're coming to you from a location near Memphis, Tennessee. And if you're listening out there in WBCQ 7490, we wish you, we hope you're getting the signal good. And hey, shoot us an email, tom@w5kub.com. Let us know where you are and give us a signal report there. Tune us in on any of the podcast carriers out there, iNet, Google Play, iTunes, any of those out there. Join our Facebook group. It's called W5KUB. Just W5KUB. Actually, you could type in Amateur Radio Roundtable, but that's too long to type in. So do that, and let's see what else. Oh, hey, hit that subscribe button. Hit the subscribe button, if you will. That will help us to advertise the channel here. Be sure and go to Jim's YouTube channel. I think if you just do a search on YouTube and just go to W6LG, it'll take you right there. That's how I get there. So be sure to go there and subscribe there. That would be great if you do that. Let's see what's going on in the chat room. Don't see anything you need to comment on yet. Oh, there's a modeling software called MMANA-GAL. Never heard of it. Don is saying that DX Commander uses that some, and we might look into that and see, because something's got to be simpler than, And like Brett was saying, hey, even if we could plot it, I'm not sure even if I plotted an antenna with the modeling software, if I would even think it was correct or right or wrong, or who knows. There's so many variables that you need to put in there that maybe aren't even being put into the model. So I don't know. Let's see. We talked about the All-American 5, talked about modeling. Hey, let me give you a report on W5KB 113. I'm getting a little concerned about 113, guys. If you guys remember, our W5KUB 112 stopped talking to us right at the 1 year mark, and it had trouble from day one with transmissions. They were getting less and less each day. We don't know what happened. We think we had some software issues on the processor. We very possibly might have lost half the antenna. The antenna, the 20-meter antenna, 17 and a half feet of that antenna is hanging below the tracker. And when you lose half that antenna, I did some testing out here. When you lose half the antenna, it will still get out, but a whole lot less people receive the signal. And it was getting where we would only get maybe a report and it transmits every 10 minutes. And used to, we would get hundreds of reports every day, every 10 minutes. throughout the day. But it was getting where we might only get 1 or 2 reports during the day. And then it was getting where, okay, we might not hear from it for 2 days. And then we'd get 1 report, and then we wouldn't hear from it for 4 days. Then we'd hear 1 report. So it's starting to concern me. W5KUB 113 is starting to do about the same thing. Now, it has been up 432 days now. And there it is right there off the coast of, what is it, Baja California, I guess, off the coast of Mexico. And we've still got a good altitude, around 47,000 feet. But guys, we got 1 transmission from that today, and the total 10 hours of sunlight, we only got 1 transmission. It came in about 10 a.m. during the sunlight, about 10 a.m., and we didn't get any more messages. So I don't know what's going on there, and we only got about 3 or 4 people picking this whisper up. I think one in Hawaii picked it up, and maybe 3 people in California picked it up. So I don't know what's going on here. I don't know if the tracker, again, this is the second one now. After about a year, we're starting to see some problems. So I don't know if the tracker is starting to wear out after about a year, or if the antenna is breaking off. I don't know what's going on here. Now, there are issues going over like Europe. There's a lot of GPS jamming going on, which we understand that causes a problem. And there are some areas in the world where the signals just aren't very good at all. But where you see it right there, we ought to be bombarding all of South America, all of North America, even some Asia right there. But we're just not getting out right there. So I don't know. This guy has been a real it sets some I can't think of the word. It has progressed to where it has gone places that others have never gone, and it has really set a long period record of flying. I hope it don't end after 440 days because the transmitter stops. From all indications that we're getting back there, everything's looking good on it. The altitude and everything's looking good. This thing could fly another year, but if we don't get reports back, we don't know it's flying. So tomorrow, we'll probably get another report. If not, in a couple of days, we'll get another report, I guess. So, I don't know. Is this the one with the circular photocells? This one's actually, we call it W5KUB 113 Heavy. It's about 3 times the weight that we normally fly. This one's up almost at 18 grams, and it actually has redundant solar panels at 45-degree angles to pick up very low level sunlight at the horizon. So I don't know what's going on here. This one does have a 100 milliwatt transmitter on it. It's a PA that we built and put on there. We ought to be hearing it a lot more, but as long as it'll report to us every couple of days, we're happy with that. All right, so that's the update on 113 right there. Okay, so hey, Brett, you were wanting to talk to us. Is it about bonding and grounding, maybe? So what we're talking about? Yeah. Well, let's jump into that, man.
Okay. Well, last time this is again a picture of me on the tower that I was on that I was on this week. The picture is from earlier in the summer, though, so you can see that you got this beautiful, brilliant sky behind me. It was not that way today. It was overcast. But I'm checking everything for the winter, and one of the things I always check is the grounding and bonding, and that brings to mind what I'd like to talk about today, which is what do you do? At almost every hamfest, someone says something or gives some kind of a talk about grounding and bonding. But in practical terms, what do you, as a ham, most often need to know in order to do that? So what I want to do is share my screen if I can, and I'll show a really simple diagram of what most hams are going to need on their houses in order to have proper bonding and
Wait a
grounding.
minute. I've got to turn on sharing. There we go.
Okay. And there.
All I'm seeing is your password to your bank account. Oh, there it is.
Oh, really? Okay, there we are.
There it is.
Okay. Anyway, this picture shows what most people are going to have on their house, at least if it's a recently built house. This is basically this is from the National Electrical Code. Actually, this is modified a little bit by a fellow named Mike Holt, who was part of the committee that makes the National Electrical Code. If you want to see the actual code, you can go to nfpa.org, and they now allow you to view parts of it for free. So you can log in and do that, so you can actually read the entire section. Now, the National Electrical Code mostly talks about the high voltage electrical wiring for houses. And so most of the information about grounding is in chapter 2 of the code very early on, and it talks about how to ground the power for your house. And so this shows that. It starts out by showing the electrical meter and your breaker panel and the ground wire that comes down out of your electrical meter. Every home has to have a couple of ground rods, at least if it's up to code. And so your system, the electrical system in your house is going to have a couple of ground rods that are bonded to the ground bus in your breaker panel. And if it's a newer one, it's also going to have something else. It is also going to have what's called an intersystem bonding connection, which is basically a bus bar that sits on the outside of your house, and it's designed for you to bond things to that you want to ground other than the stuff inside your electrical system. And this is very handy if you've got it on a house. And again, if it's recently constructed, you do. This is a very handy thing. If you don't, you can install one, or you can just go ahead and clip right on to the electrical system here, and I will show a couple of devices that you can use to do that. Now, this diagram, so again, this diagram shows what's in chapter 2, but then what the electrical code does is it all the way out at the far end of the book in chapter 8, they talk about what do you do with antennas. And they talk about receiving stations, and they talk about they talk a little bit about satellite dishes and ham radio antennas. And what they say there relates back to how you connect all of these things back to your main grounding system. Now, the first thing you should know is that everything does need to be connected together. Don't get the idea that you should separate. Somehow it will improve things by separating the grounds for your antenna system from the electrical system. All that will do is create potential differences between your antennas and your electrical system, and the path between those two can go through your equipment and blow it out. So you don't want that. You want everything bonded together, and that's what they talk about. Not only grounding, but also bonding. All of the grounds have to be connected to one another. Now, this diagram shows an antenna. It happens to be a satellite dish, but the principle is the same. It shows a little antenna mast. In this case, it's a J-mount attached to the side of the house, and it has a wire which is running back again to the to that intersystem bonding termination, or again to one of the other grounded metal parts if you don't have this connector here. Now, the rule, if you have an antenna mast on your house for a ham radio, you've got to ground it the same way. And basically, the rule is that it needs to be at least as thick as any conductor in the antenna. If you have a very thick, heavy antenna wire, you need to make it thicker. But it should also be a minimum of 10-gauge wire if it's copper, or 8-gauge wire if it's aluminum, or for some reason, and I think the satellite companies lobbied for this, it may not really be the safest thing. You can go, if you have copper-coated steel, you can go down the 17-gauge. And I think that's just because that's what they put in satellite cables. It may not be the safest thing. I'd probably go thicker anyway. In any case, if you have a mast on top of your house that's holding up a ham antenna of some kind, definitely do that. And again, I would recommend going with at least the 10-gauge wire. If you can go for something thicker, by all means do that. It never hurts to have it thicker, but you don't want to have it any thinner. Now, that goes back to your intersystem bonding connector, or again, back to your main house ground. Now, the coax they show here goes around and down and comes back up into what they call an antenna discharge unit, which is basically a UL listed lightning protector. Now, last week I showed some lightning protectors, but none of the ones that I showed are UL listed, and therefore they wouldn't qualify to be this antenna discharge unit. Fortunately, the code makes an exception. It says you don't need the listed discharge unit so long as you have grounded the shields of the coax to the intersystem bonding connector, to your grounding system. And so that's really the thing to do. Go ahead and get a big, thick grounding bus plate and ground your coax to that. And then you don't have to have the listed ones, which are they're really only made, again, for satellite dishes and for TV antennas. And then go ahead and put in one that's especially made for radio equipment, such as your HF or VHF transceiver. And that will get you around that will get you around that requirement, or should I say, it will satisfy that requirement, and you'll be okay. Now over here, they also show the telephone system. For those of you who do have wired phones, those also have a lightning arrestor and a connector that goes back again to your common system ground. So that's the way everything gets connected together. Now, what if you have a tower? Now, if you have a tower, you're probably going to do more than this. If you have a tower, it's probably going to have, or it really should have, several ground rods coming off of it. And those ground rods should be separated by at least their length. They should be pounded into the ground, and you should have several of them. And you should have a wide ground field to make sure you get some decent connectivity to the earth. But then they also need to be bonded back to this intersystem grounding termination. And when you do that, you have to use at least 6 gauge wire, which is pretty thick. I actually go one thicker, and I would normally use number 4, or even bigger than that. The lower the number, the lower the gauge number, of course, the thicker the wire. And so what you do is you take the tower and the ground rods that go with it, and run a wire, bury it, so you don't trip over it. Bring it back to the house along with your coax, and attach it to this same bonding connector, and you should be okay. Now, the other thing you should understand is that if you disconnect your radio, and we were talking about this a little bit before the webcast started, make sure that if you disconnect it from your radio, you don't disconnect it from its ground, because if you don't keep your coax grounded, you've got something there which can spark over and still cause a lot of damage. And you certainly don't want that. Now, if I can terminate sharing here, if I can figure out where I do that on this screen, let me see if I can. I will show you some of the devices that you use to do all of this grounding and bonding. Let me see.
Down at the bottom center, maybe.
I'm clicking on
where it says sharing. You should see a turn off sharing, I think.
I'm looking for it.
On my multiple display, there's a share screen button right on the bottom.
Yeah, and it disappears when you share, so I need to figure out where it went. Let's see.
It's probably going to be up at the top of the screen, then. I think that's where it goes.
I'm looking. Let's see. It doesn't say end
You
sharing.
know what? I might be able just to do a hocus pocus.
I
might be able to do some magic, and I may.
I found it.
I brought you in.
I moved my cursor up to the top of the screen, and the stop sharing button appeared at the bottom where I wasn't looking.
Yeah.
That's why. So anyway, here we are. Here we are. Now, when you want to attach your ground wire to your electrical system, again, if you've got an older house, if it was even built like before the 1990s, it may not have that really nice intersystem bonding connector. So how do you connect the grounding wires? Well, I've had to deal with this a lot because I'm a wireless internet service provider, and I have to ground all those antenna masts for that. And so I have some hardware, which is really good for that. Here's an example of one thing you can use. This is a little triangular clip which can go around the edge of the electrical panel, either the meter can or the breaker box, and you tighten this screw down, and it tightens it snug against the middle, and then you can put a wire under the nut, which is here again. If you can take a look here, there's a nut which comes down, and this will tighten the wire on, and then you've got a place to put a grounding wire. There's another clamp which you can also use, which is called the California clamp, because I guess the state of California likes you to use this one. And this has 3 screws and a little lip which goes around the edge of the box. And this is also a clip that you can use to connect to your electrical panel or your meter cap.
It's kind of the shape. It's kind of the shape of California. Actually, look at it.
Yeah, kind of. You're right.
Yeah, kind of.
Yeah. And then finally, what if you live in a mobile home? If you live in a mobile home, you've got a pedestal, or even a modular. You might have a pedestal outside with your electrical meter, and then the wire runs under. There's no meter can right on the mobile home that you can use to attach. And so I bought this from a company that supplies satellite installers. There's a little clip here that also has a place, a couple of washers under which you can put a wire. That's called a trailer clamp. And what you do is you get underneath your trailer or your modular, and you scrape some of the paint off one of the metal beams that runs under the bottom, and then you tighten this around that, and it clamps down and gives you a good connection. And because the way trailers are built, the code says that those metal beams across the bottom have to be grounded. Then you've got a ground which is the equivalent of a house ground. And so if you do one of those things, then you can ground your antennas, you can ground it, or you can ground your coax, you can ground your electrical equipment, you can make things safe. And so that's, in practical terms, what most hams have to do. There are a lot of more complicated requirements that you might encounter, but in particular, there are all sorts of fancy requirements for certain special situations, but that's 99% of what you need to know. And so that's pretty much what I have for today. If there are questions in the chat, let me look. I can go ahead and answer those. Let's see if we got any.
I didn't see any questions, but you're talking about bonding, and the reason it's important to kind of bond them together is to reduce that potential difference. It can be, there's a lot of cattle that get killed every year. Lightning hits the ground somewhere and it kills cattle. Well, it's not because the lightning struck them. It's because it traveled through the ground and I guess up one leg and through the body and down the other leg. And hey, I don't know if you've done this, but I've even in lightning storms, I've stood on 1 foot out there.
Well, I've been zapped by lightning when I was on the telephone, on an old-fashioned wireline telephone, and lightning struck nearby, and it zapped me right through the phone line.
Oh yeah, yeah.
So that definitely.
Yeah. Well, you're talking about the National Electrical Code, guys. Look, to show you how up to date I am. Look, that's how I'm up to date right there, guys. But there's a lot in here. There's 800 pages. 800 pages in this one. I don't know what the new book is, but hey, there it is, and it's in writing, and a lot has gone into it.
There's also a pocket version that's shorter and just summarizes some of the important points that electricians often carry. Brett, do you want to discuss the difference between bonding and grounding, because it is in the electrical code?
Well, no, it's people make a big fuss about it, make it really complicated. Grounding means connecting things to your ground system, and bonding means connecting all those things together, is basically it in one sentence. And it don't have separate grounding systems. You can have multiple ground rods. You can have a fancy multi-point grounding system, but in the end, everything has to be bonded together for it to be safe, because otherwise you can get potential differences, as Tom was mentioning, between one part and another, and that's when you can really get into trouble.
Yeah, everything has to go back to that inner system bond. Everything in your station goes back to that. Yeah.
All right, here's a question. I don't even know. I've never heard of this FIRBO, F-I-R-B-O. You know what they're talking about? Furbo?
Not
Could you
sure.
use, let's see, now what about Furbo? Do you ground for that? I have no idea what that is.
Bert, what the?
I'm
Well,
betting it's fiber.
Oh, well, I don't know.
oh,
Did he mean fiber? Yeah. Well,
Yeah, I'm thinking it's fiber.
yeah. Fiber is not conductive by itself. You do have a little bit of copper equipment there, but
yeah,
but there's you don't have to worry about the fiber itself because it doesn't conduct.
Yeah,
yeah.
that's what he's talking about. Yeah.
And you want to, Brett, also, do you want to mention the UFR ground?
Um, well, that's one kind of ground that you may have in your house as a ground rod that will go. Basically, an oofer is a piece of rebar that's usually inserted into your concrete foundation, and because your concrete foundation is often in contact with the water table, that makes a real good ground. Back in the olden days when we used copper for everything, you'd also ground to a copper water pipe. And there's still a requirement in the code that says if you got a copper water pipe coming into your house, that's one of the things you need to connect into your grounding system. Nowadays, though, people use PEX. And so there really isn't a copper water pipe to ground to anymore. So you don't have to bond that, obviously, if it's plastic.
Yeah.
But if you find that, but one thing that you do have to do is if you do have copper pipes and you have a water heater, you have to bond across the water heater from the hot water pipe to the cold water pipe to make sure that those are connected. You don't wind up with a hot water pipe that's floating and not connected to the ground system.
Yeah. The UFR ground is a number 4 rebar or larger bent in the shape of an L, and it's tied to the rebar before they pour in the footing, and it sticks up, I forget how many inches, 6, 8, 10 inches. And then it goes into up the wall to a box that's in the wall usually. And that's where your intersystem bond is. That's where everything is tied into that box. So for some folks, it's going to be hidden in that box. And the only way you could do it is those clips that you have, really, for a lot of things, because you can't get access to some of these things. And many houses will have one UFR ground. Houses today will have, what is it, 2 driven rods, Brett? Is that
these days you will have at least 2 grid? Yes, and that's a good picture.
2 driven rods?
You will have 2 driven rods at least their lengths apart on the outside of your house, and
That's right. Yeah.
Nice thick wire running back to the meter. Now, if you want to clip into that, don't just take it and take your wire and wrap it around it. I've seen people do that. It's not very effective, and it can get corroded. Use a proper pressure connector like this. This is a split bolt, and this will connect 2 thick copper wires together really well. And this is what I use when I'm connecting things to the wire on the outside, and I don't have that nice intersystem bonding connector at all, or I'm connecting someplace where it isn't nearby.
Cool. Yeah.
So I'm just looking to see if we have any questions in the chat. Okay.
Well, somebody mentioned the plastic ground rod. I have a picture there, plastic ground rod. So.
Yeah.
Oh, what? Oh.
That's interesting.
Yeah.
Okay. Well, let's see. Yeah, there's a question in the chat. My service is at the opposite end of the house from my station and tower. And yeah, that often happens, and it's not convenient. Just use a nice thick wire. No matter how inconvenient it is to get a wire from one end to the other, the electrical code does require it. And so go ahead and run it. If you don't think that if you think that it's not going to be a good ground because you have to run it a long way, go up to number 2 wire. Go up to or you use number 2 copper braid. But make sure you do connect everything together, because otherwise there will be a potential difference between the grounds in your electrical sockets and the grounds in the rest of your system. And again, you can get you or your equipment can get zapped.
Now here's an interesting ground right here.
Let's have a look at that.
Right, if you can see that, yeah.
What the heck is it?
Can you make it out? I mean, I'll just blow it up a little bit more for you.
Yes, well, it looks like what you've got there is a plastic cover over your intersystem bonding connector.
No.
Underneath that, you
Oh,
will,
oh.
or you're going to have the bus bar that I was talking about before.
Yeah, yeah. All right, I got to find a better picture for that. Let's see.
Yeah. If you see that on the outside, if you see that, that little white cover or something like it on the outside of a house, that means you have the connector. You just have to pull the cover off. I'm sure we can find pictures of what's underneath there.
At the station, it's important to not daisy chain. What you're saying, Brett, is not to daisy chain the equipment, but to run it all to a common point ground. So you can have a bus bar at your desk or something, and then connect a wire to that to run to become the ground conductor, to grounding. See, I said it. The bonding conductor to the ground conductor. So each piece of equipment has its own strap to ground or its own wire to ground. So they're all at the same potential. So they all kind of rise and fall. So you don't daisy chain them because you'll have a differential voltage between one box and another, right, Brett?
Yes, and I don't know if Tom can find a picture of it, but what I have under my desk in my shack is a very large copper plated metal grounding plate, which has lots of holes in it that I can use that I can use to bolt things to. And I put my lightning protectors on there, and all of the wires that go on to ground my radios all go back to that. And then that has a very thick wire that goes out of the shack and to the basement where it connects to the ground bus on the electrical panel, which is one of the places where you were allowed to ground things.
So,
If you want to find out where those places are that you're allowed to attach, if you're not near that intersystem bonding connector, you don't have one. It's it is paragraph 250.10, I think, of the National Electrical Code. It's very early on, and it gives you a list of places where you can connect to the grounding system safely.
I thought it was 250.10, paragraph B.
It might. I don't remember what I think. I think the whole section.
There, how you like that ground rod right there?
Oh, there you go. That's a real effect. Oh, it's in the earth.
That grounds the generator. That grounds the generator right there. So, yeah.
But in any case, be safe, and there was no shortage of information out on the web about how to do things.
And Tom Holt, I've talked to him on the phone a couple of times. He's great. I said that right, didn't it? It's Tom Holt. I didn't make a mistake.
I think it's Mike Holt.
Yeah, Mike Holt. Okay, that's why it was. He is a great resource. He has a lot of videos, a lot of written material. I've talked to him on the phone. He thinks ham radio operators are kind of crazy because we put up all these antennas and things. But he's a great resource. If you need to find out about bonding or grounding or something electrical, he's a tremendous resource.
Yes. And he is one of the major contributors to the National Electrical Code. He's there at all of the NFPA meetings.
Yeah, he knows the code inside and out. It's just amazing.
Mm-hmm. He also does sell instructional videos if you go to mikeholt.com.
Yeah. There's no such thing as an RF ground, but this room, I've got everything bonded together. And so I was looking for a way to get to the electrical panel like you're talking about, Brett. And I went up into the attic, and son of a gun, there's a 1-inch copper pipe right above my head that runs all the way to the electrical panel, and it branches off for other stuff. So all I had to do was connect to that. The other end of it's already connected to the intersystem bond. So sometimes you get lucky and you have things like that are available, maybe up in the attic or below the floor. Nose around, see what you can find.
Yep, and that's the same thing you do with the trailer. If you have something at the far end of a trailer or a modular, which has again there'll be steel beams holding up the floor.
Mm-hmm.
any point on that is going to be electrically connected to your electrical system, and it's fine to ground to that. So
that's a pretty big conductor.
yeah. And in a metal building, if you happen to have if you have to have a metal industrial building, a lot of people have their man cave is an entire building. If you're lucky enough to have one of those, a deluxe man cave, then all you really need to do is bond to the structural steel, and you should be okay.
All right. Well, thank you for telling us all the ins and outs of bonding or grounding there.
Yeah, and again, they give every year at DX University and various other things. They will cover that. I think what is the one that they have at Dayton? Is it DX University or something like that? A series of
something university.
Yeah. In any case, they have they will always have sessions on that. You can also find sessions online. There's tons of information about this. I'm just summarizing.
Mm-hmm. Okay, I was looking for more grounding pictures here. All right. Well, guys, thank you for everything tonight. I think we've had a pretty good show. A lot of good information. And we are not going to have a contest university is what it's called. Thank you, Dwayne. So, guys, we're not going to have a show the day after Christmas or the day after New Year. We're going to take that off. And Jim may or may not be with us. Our next show, Jim is going to start some chemotherapy, I think, early January, and we wish you good luck with that.
I'm not looking forward to it.
Yeah, I know.
Yeah.
So anyway, we wish you good luck on that, Jim, and hope everything comes out and works out okay for you there. And let's see, my Zoom is messed up now. Let's see, remove. Okay. I can't change my Zoom now. Let's see, hide non. That's not going to be it. I need to take me a lesson on Zoom. Full screen. Gallery. There's gallery. And I want speaker, but it doesn't work right. Oh well. Show's about over anyway, so.
Brett broke it when he was talking.
Yeah. What a mess.
Oh, power user,
what a mess. What a mess. Huh. All right, guys, so we're going to go ahead and close the show down tonight. It's about 9:30, and it's time for popcorn. So good night, and let's see. We have one more show between now and Christmas, I guess. Yeah. Next Tuesday night, Christmas is coming soon. So, guys, I hope everybody gets all the Christmas toys they want and all the radios and all those kind of things. So we'll say good night to you and 73, and we'll see you next week. And 73 to everybody in the chat room there. Glad you're with us tonight. Thank you.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question.
Well, Jim, good luck with the chemo. I know some people who've gone through it, and it's never easy, but it's necessary.
I had 5